class. In yesterday's class, we stopped psychological characteristics of color. We saw in the last class. We started with color model. We saw how color model works, what is a color model, and some examples of color model. By taking an initiative as a primary concern, we started with what are primary colors, what are the primary colors which have been used in color models, and then we saw what is a color gamut. Then we saw some complementary colors, that is nothing but combination of two primary colors. To do remember, complementary colors are nothing but combination of colors with some proportions, where the production of this complementary colors might be white as well. Then we saw some concepts related to intuitive color concepts. Then we saw how shades, tints, as well as tone works. What are those? Oh, by which proportion as well as what combination of color is mixed so that you'll get some shades, tints, as well as tones with respect to each other. So there is an example of shade, tint, as well as tone in the slide. Then we saw types of color models, that is additive as well as subtractive. So what was additive as well as subtractive? Where additive is nothing but we get this color with the help of transmitted light, whereas subtractive model is nothing but this is an resultant of reflected light. Reflected light. These are the examples of, or I can say, these are the definitions of these two models. Then we saw how a color model works, what is a color model, and then basically what are the combination of the color models. If what color is being mixed, what color you get. That is nothing but combination of colors will be your complementary colors. So this is how you get these CMY colors, that is cyan, magenta, as well as yellow. By combining what kind of colors, you get this. There is one more equivalent functionality given with respect to this color. If you are reducing red color with respect to white, you'll get this color, that is cyan color. Similarly, with respect to green as well as blue, you will get magenta as well as yellow. You need to remember the combination. If what combination is mixed, which color you will get, that is the complementary color. Then we saw an important question, that is nothing but RGB color model. We saw how an RGB is represented with respect to an picture. Then we saw what is RGB, which is actually an additive model, which is used for computer displays such as I can say raster scan as well as random scan displays as well. Then we saw what we get with the combination of all the three, which is RGB, you'll get white. Then we saw the color model in detail with respect to RGB. Then we saw an color cube, that is nothing but RGB model. This is actually said an RGB model, where this is a representation of combination of colors, where if you mix some colors, you will get another color. If I represent green as well as red as a combination of colors which is to be mixed, the resultant of the color will be yellow. So this is how RGB color model works. This is a real-time snapshot of an RGB model where combination of colors is being represented. Then we saw in detail how this model works with respect to every color. Then we saw the combination of colors. What is the representation with ones and zeros, so that you will get that particular color with respect to color model. Then we saw some representation as well as example with respect to RGB color model. And then we saw RGB color model with the help of color gamut, by giving an example of National Television System Committee, which uses and standard RGB primary colors so that it can represent the video or the audio which needs to be presented onto this screen. So we saw an example of RGB color model for CRT, that is cathode ray tube displays. Then I am supposed to start here. So we'll start up with this. This is another model, that is, as I told, there will be different types of color models. In your syllabus, there are two models, that is RGB as well as CMY color model. Basically, RGB is an additive color model and CMYK is an subtractive color model. So we'll check out what is this CMYK color model. Basically, CMYK is a standard color model. I can say CMYK is a subtractive color model. Subtractive, as I told, the difference between RGB as well as CMYK is this only. That is additive. This is subtractive. The definition of CMYK color model is as follows. It is a standard color model used in offset printing for full color documents. Because such printing uses inks of these four basic colors, it is often called as four color printing. For color printing, what is the application of RGB? As I told, it is not much used in not almost all the printers. There is some specifications regarding to it. The CMYK color model, this is basically used in all printing machines actually. This is basically used for printing. Whatever the document you want to print with huge number of color applications, you can use this kind of model, which is nothing but CMYK color model. In CMYK color model, two colors of RGB overlaps. We see a new color formed by mixing of two additive primaries. These new colors are These colors are obtained with the help of CMYK model, which are nothing but combination of two colors. If you combine red as well as the other color, you might get another color. So if you mix the primary colors, what are the primary colors? What are the primary colors? We studied, right? No one
Red, blue,
remembers.
green.
Yeah, that is RGB. RGB are represented as well as said to be primary colors. So mixing of as well as combination of primary colors results in some other colors. That is nothing but the output of, or I can say the result of CMYK color. A greenish blue called as yan, a blushed red called as magenta, a bright is called as yellow. The key color is black. After mixing all the colors, the resultant of this combination is black, whereas the different color combination is given as some different colors here. So CMYK model, as the name says, check out here. C represents yan and magenta represents M, Y represents yellow in the model. So this is the CMYK model. This is how CMYK model is being defined. Then let's see how CMYK model works here. What happened in RGB? We used some colors, right? Red, green, as well as blue in the representation of the model. But check out in the diagram here, the cube, that is representation of the color model here. Check out here. If you are mixing cyan as well as magenta, you will be getting blue. Okay. In the previous slide, that is in RG, what did you get? If you are mixing some color that is red and blue, you got something here, right? So it is a reverse of that. Okay. You are using cyan as well as magenta so that you are getting blue. If you are using gray as well as another color, you are getting red. Similarly, if you are using cyan as well as another color, you are getting green here. So this is how CMY color model works. But this remains the same. The origin remains the same. That is nothing but white, and the diagonal of that particular origin will be black here. So this is the color representation with respect to the model. We'll check out the theory part of the CMY color model. Color models for hard copy devices such as printers. As I told, this color model is basically used for hard copy devices, which is nothing but printers. So that is nothing but for printing a huge number of applications. For printer specific applications, this kind of model is used. So what happens in such models for such hard copy devices? It basically produces a color picture by coating a paper with color pigments. That is nothing but you are printing a color copy, that is a color the whatever document you are printing, whatever document you are printing, the model is printing color words in that. Okay, then it basically obtains color patterns on the paper by reflected light, which is an subtractive process. What is the basic of subtractive model? It is obtained with the help of reflected light, right? So simultaneously in CMY color models, it basically obtains color model with the help of reflected light. That is nothing but reversing of the light. It is reflecting for that particular model there. Then there are some parameters which you need to remember in CMY model. That is, a subtractive color model can be formed with the primary colors. That is, these are the three colors. As I told, CMY represents the colors yan, magenta, as well as yellow with the help of these primary colors. As we know, primary colors are RGB, right? But in CMY color models, it assumes the primary colors as these three. In subtractive color model, how it is formed is basically with the combination of these three, that is CMY. Then unit cube representation for that particular model with white at an origin is represented in this particular cube. Suppose if the question is asked for CMY color model for the representation of this, first you need to represent this terminology's definition, why it is used, and this diagram. Then you should start up with the application. One is a small application of CMY color model. Then you need to represent the parameter with the cube as well here. Then we have some terminologies as well with respect to CMY color model, which we'll be checking out in the next slide. Yeah. There are some more examples, or I can say some applications with respect to CMY color model. It is basically used in hard copy devices such as printers, which is one of the example. The printed color that looks red absorbs the other two components G and B and reflects R. What does this tells is basically if you want to represent red, if you want to print red color, when is this red color obtained is it is basically obtained by two components, that is G and B. Basically these two are combined and absorbed. What does it mean? Absorbed. Absorbed in the sense the red color which is being represented, it basically takes out both the colors, that is G and B. Then it will represents red, that is R here. Then thus the CMY coordinates are just the complements of RGB coordinates. That is nothing but the complements of RGB are CMY with respect to RGB as well as CMY models here. Then we have something called as transformation as well. There is some comparison done in this diagram. Check out, this is RGB and this is CMYK. So check out, with the help of CMYK, there is some blurriness in the colors which is being represented with when compared to RGB. You can see clear pictures, right, with respect to RGB models, but in CMYK there is slight difference with respect to the color there. Then we have a transformation between RGB as well as CMY, which is represented with the help of this matrix. So what is this transformation between RGB? Basically, if I can tell, CMY models give a combination of cyan as well as yellow, which basically produces green light because the red as well as blue components of the incident light is absorbed, as I told in the previous slide. Then other color combinations are basically obtained by some subtractive process there. So as I told, the CMY model are a subtractive process. It is possible to get CMY representation for RGB representation with the help of this conversion. If you want to get CMY, you should just take the RGB values. You should subtract the RGB values with respect to the particular colors, which is being represented as 111. Then this transformation matrix of conversion from CMY to RGB. You are getting CMY colors from RGB colors. Okay, do remember, if you have RGB colors, then only you will be getting CMY color. Okay, if you want to get RGB colors from CMY, you are just representing that in this format. That is nothing but the unit column vector. That is the unit column vector. I can tell this is an unit column vector, which is an RGB representation for white, and this is representing the unit column vector, that is white color here. You are just subtracting these colors with respect to white color, and the CMY representation is for black with respect to these two matrices. The conversion from RGB to CMY is given in this format, where white and black color is being represented. You are just subtracting as well as the previous part, that is with respect to RGB, you are just subtracting that colors with respect to white as well as black. Okay, hope this CMY color model is clear. This is actually easy when compared to RGB. Both the models are easy to be remembered for your internals as well as externals. Then there is some one alternative CMY model, which is a CMYK model, which basically stands for black. In this model, the K stands for black, which is also used in color printing. Example, to produce darker black than simply mixing CMY. We have some terminologies how to get K, C, M, and Y. You should take some minimum color with respect to CMY. If you want to represent cyan, that is yan, you should subtract this C, which is initiated in this color, with K, that is nothing but black. Similarly, M and Y. Basically, in CMYK model, why K is used instead of equal amounts of CMY. That is nothing but if you want to represent CMY, you should know why black color is being used in that particular model with equal amount. Why we use K is we call this K under color removal. If you want to remove some color with respect to CMY model, we'll be using this black color. We what kind of black color is? It is a dark black. I can say it is richer black than. Then less ink deposited on paper, dries more quickly. Why this color? This is an advantage of black color using in CMYK. So, hope both the models are clear to everybody, RGB as well as CMY, CMYK models.
Yes, sir.
Yeah, okay. I have listed some basic applications of both the models, which is RGB as well as CMYK. Check out why RGB has a huge number of applications. Why this is? As this is very simpler when compared to CMYK, this is just used in printing purposes. Check out the RGB applications. One is computer graphics. Whatever you are using your software, OpenGL, it is totally dependent on this RGB model. Then image processing. As I told, this is an application of computer graphics. Huge number of application represents only RGB models itself. Then image analysis as well as image storage, which basically comes under image processing, where you are performing, you are cleaning some impurities in the image which you have got. So these are some of the applications of RGB. As we studied, CMYK model is basically meant for printing. That is nothing but it is only used for printing purposes. So this is the application of color models, RGB and CMYK. So this was about all your color models till now we studied. That is RGB as well as CMYK color model. As this was a starting part of your third part of your module. So this keeps a huge weightage. Okay, as I told, as I'm keeping on repeating from yesterday, this carries huge marks, 6 to 12 marks. Both the models can be asked. So we'll check out. As I told, the third part is color as well as illumination models. So we'll check out what are these illumination models in detail. So, what is an illumination model? So, first, moving on to illumination model, first we'll study what is illumination. That is discussion about how object will illuminate. An object is illuminated from the ambient light and from interrelated light source. That is nothing but first you need to remember in illumination model, as for every object, light sources very important. Similarly, in illumination model, first the object is represented with the help of the light from other sources, that is interrelated light sources. Can someone from the class, if you know, can tell me what is illumination? Any idea you have regarding illumination? No. Illumination, to be very simpler, illumination is nothing but giving light. That is nothing but you are lightning, or I can say it is just a light. Basically, the higher levels of illuminations are needed for reading with respect to this particular concept. Basically, you just remember illumination is nothing but some kind of light with respect to that particular model. How an object is illuminated is it is just with the help of ambient light from which the light source is been getting, which is related to that particular light source. There are some important concepts with respect to basic illumination models, that is ambient light. Where does this ambient light is coming from? This light is coming from the nearby objects after reflection. Basically, you get ambient light only after reflection. If there is an another object nearby that object, whatever the reflection happens, that is nothing but the ambient light. Then there are another components, that is diffuse as well as specular reflection with respect to illumination models. There are some properties as well with respect to illumination models, that is object illuminates on the basis of some properties, that is intensity, type of object surface, the surface colors. These are the simple terminologies, need not be explained. That is some intensity of the light, the range of that particular light is dependent to represent the illumination of that particular object. Type of object surfaces, that is whatever the surface above which the object is kept plays an important role, as well as color of that particular illumination model. Basically in illumination model, or I can say in shading, we keep on developing some models with some approximation of world objects. That is nothing but the representation of world object is done with the help of illumination model. So these are the basic concepts you need to remember with respect to illumination models. Then coming on to the actual part of illumination model. So what is an illumination model? Suppose a real world image taken by a digital camera will only capture a small subset of the light rays passing through a small area. Often an approximation wave is generated using these formulations, which I can tell as illumination model. So if you take an example or application of your camera, what does digital camera does? It takes some part or some portion of light, wherever light is being reflected on an object, that area is being captured with the help of the camera, but not all area is being captured. If you want to capture the whole area of that particular compartment, if I can say, you should use some videographic options with respect to that particular model. But if you are just using a picture option there, a small portion of area is being captured with the help of camera. For this, what happens is basically an approximation is generated using these formation of algorithms, that is complex formulation as well as different algorithms with the help of illumination model. You can represent this as an example of illumination model. Then we have something called as hardness of illumination models. That is how this illumination model is represented if there is some vulnerability in that. I can say a word called vulnerability with respect to illumination models. We'll check out the first point with respect to the illumination model, that is the vulnerability with respect to illumination models. Basically, a object is illuminated only not only for the direct light source, but also from the light which is interreflected from nearby objects. This is nothing but when you get illumination of light, that is illuminated light, that is with the help of illumination model. That is, a object is illuminated not only on the direct light source, but with respect to the reflection of the object as well. So if there is some reflection from any of the object, you can say there is an illumination light is being coming out. Okay, that is illumination is coming out from that particular reflection. Then there can be infinite number of light rays coming from the nearby object to illuminate the object, to illuminate a particular object. That is, I can say there is a huge number of rays coming from the light source. As we all know, there are just two light sources, right? Excuse me, students. One is sunlight, which is the natural light source, and the artificial light sources, I can say your light bulbs and so on, the other terminologies there. So if with the help of that light sources, I can say huge number of rays are coming from that particular light source, so that the object is illuminated. Basically, with the help of light source itself, the object gets illuminated. In illumination model, it is very hard to find out all the interreflected light. That is nothing but whatever the rays which you get from the light source, you have some interreflection in that particular rays. So it is very difficult to find out which is related to that particular ray, or which is not related to that particular ray, or which is partial, that is reflected or interreflected with respect to that particular light source. It depends on the light source, which kind of ray it is passing. To compare and to make database for these kind of rays is not possible. As you all know, there is no database available for light sources, because if there is a database also, but the terminologies with respect to that particular light rays cannot be represented simultaneously. That is perfectly, I cannot represent the database there. Hence, the image created after considering illumination model is only an approximation of original model. This is one of the disadvantage of the particular illumination model. I cannot get a direct original image. An original image is not an original image is not taken as an output there. I can just give an approximation of the particular original image with respect to illumination model. In illumination model, we try to capture a set of light rays which is reflected with respect to interreflection from the various approximation of original scene can be created. So how do you get this approximation of an original image is represented in this point? Basically, capturing of set of light rays is done by checking if it is reflected or not reflected or interreflected some various objects, that is reflection of the objects, and then you'll just approximate that particular original image, but you are not getting the whole complete original image with respect to illumination models. Then, hence, to get actual reality of scenes is not possible with the help of illumination models. So, I can say these are some of the disadvantages also. But if you are using this model, you can take this particular points as the advantage as well with respect to that particular model. So, these are some of the key points you need to remember with respect to illumination models. Then we'll check out how basically this illumination model works with respect to some different direction by taking some different reflection as well as illumination models here. So the first I'll check out the diagram. It basically tells modeling specular reflection. What does this specular reflection tells is basically here there is an, suppose you take an example, if you have an illumination model with shiny surface. As I told, illumination happens depending on some properties, which is one of the property was having proper surface, which is in this example, if I take a polished metal or an apple which has a soft surface with some light, we can observe that there is a brightness in the spot of that particular surface. This phenomenon of reflection or incident light with respect to that particular region, I can call it as specular reflection with respect to illumination models. That is nothing but I can tell the reflection, whatever when you have light source passing on the shiny surface, what are these? I call These are some of the reflection angles. If I consider this as a reflection angle, I can call the process of finding out the particular reflection angle of that particular incident light, that area I can call it as a specular reflection. As I told, the figure shows a specular reflection direction at a point on the illuminated surface. In this figure represents the unit vector in the direction of specular reflection. There we have some terminologies, which is L. I can tell this is an light source with some unit vector. Then what is V? V is nothing but unit vector pointing to the viewer. That is nothing but coming towards the light is reflected towards the is angle phi, nothing but the viewing angle with respect to reflection direction, that is R. This is the reflection direction R represented here. So this all specular reflection is basically happening in which kind of plane? As we started with 3 dimensions, this kind of projection is done in 3D plane. So you need to remember these terminologies, that is specular reflection, which might be asked for 5 to 6 markers as well. And this is an example of an illumination model with respect to some reflection part. That is, check out the first figure here, first picture. I'm getting multiple viewing direction in 3D scene. That is nothing but specular reflection. There are huge number of reflections happening with respect to the surface here. In this part, similarly with respect to light, there are huge number of reflections happening on the surface, that is the shiny surface, but there have the directions is different. Check out here, the direction is going apart from the surface, but here it is coming inside the surface. So why is this? A light source may come from various direction as well, due to more than one light source, right? This is a key point. This is an not exception, I can tell. This is an default, right? You can get the direction of many lights from many light sources. You can get many rays from huge number of light sources due to interreflection of light from various objects, which basically represents that particular scene in the particular illumination model. You need to remember, in illumination model, under specular reflection, you can get multiple viewing direction as well as you get different light source may come from different directions with the help of different light sources. So this is an exceptions you need to remember with respect to illumination models. So now we saw something called as ambient light in the definitions as well. So we'll study what is ambient light. So in ambient light, I will just tell what ambient light is. Suppose if you take a surface of an object which is not directly exposed to the light, that is light source, which will be visible if nearby objects is illuminated. That is nothing but reflection of objects is happening. A simple way for that particular model, you will get combination of reflection from various surfaces so that you will get ambient light. So what is ambient light is? It is nothing but a surface which is not exposed directly to the light but still be lit up by the reflections from nearby objects. Suppose, check out here, if you want to see this particular object, you need to represent this particular object. Yeah, this is the light source which I'm getting, but there is another object here. This light is been reflected here, but this is not directly reflected on this particular object, right? This is reflected with respect to this object, then hit to this object, and then you get the point. That is nothing but ambient light of that particular object. If I consider another part, if the light is directly exposed to this particular object, but you want to represent this object's representation onto your outputs, then if you want to see this object, the light is reflected. That is nothing but you are not getting direct light onto the object. You are getting this light is falling on this particular object and then reflecting that particular image on this object, and then you'll get the object image as the output. So this is the ambient light, where what happens is there is no direct light. You are just getting the light from another resources as well. That is, the surface is not directly exposed to the light, but you are still, the object is still lightening up by the reflections of the nearby object.